Hey guys, Mr. Milton here. Today we're going to talk about space figures and nets. At the end of this video, you should be able to identify the faces, edges, and vertices of a polyhedron and tell how many of each there are. You should also be able to sketch a polyhedron from a net and sketch a net from a polyhedron. Okay, so in this unit, we're dealing with three-dimensional objects. I'll just call them 3D. Talking about 3D objects. Okay. A polyhedron is a three-dimensional figure whose surfaces are polygons. Okay, a lot of definitions here. You'll have to make sure you look at them and are familiar with them. A face is the surface of the polyhedron. Again, the surface is a polygon. An edge is a segment formed by the intersection of two faces. A vertex is a point. Vertex is a point where three or more edges intersect. And then a net is a two-dimensional pattern that you can fold to form a three-dimensional figure. Okay. Now, the following polyhedron is a cube because its faces are square. Okay. So if we talk about this here, this is a vertex, that point there. This line is an edge, and then this surface, all that, is a face. Okay, now you'll see here that we have a net here, and we can actually use this diagram to make a cube. Okay, so what you have to practice doing is visualizing basically these two-dimensional figures being three-dimensional figures. Okay, so I could fold that up, fold this up, fold this up. The 6 would be on top. Okay, so take a second look at that and see which faces would be opposite of each other. Okay, so I can see that 2 and 4 would be opposite of each other. 1 and 5 would be opposite of each other. 3 and 6 would be opposite of each other. Kind of difficult sometimes for people to visualize those, but that is a skill that you can practice with this during this chapter. Okay. All right, flip it to the back. Okay, so on the back here we have the directions to sketch the polyhedron that would be formed by this net. Okay, so I'm not going to ask you like cut paper out or anything like that, but again, another practice in visualization. If I fold here at the edge here, fold here at the edge here, you can see I have a triangle. Fold here, kind of have like, I'll call it a roof of a house, okay? And it's actually a triangular prism. We'll get into that a little bit more, but here you see what our polyhedron would look like. Okay, do the dashed lines to show the edges on the other side through the object. Okay, and so that's where we have it. Two triangular bases right here, have a rectangular face, and two other rectangular faces. All right. Okay, here we're going to draw a net for the pyramid below, four sides, so it's a base here. And these nets can look a little bit different, but I usually try to start with the base. I've got 1, 2, 3, 4 faces, and so I'm just going to draw 4 triangular faces here, here. Okay, you can see if I fold these up, then I would have my pyramid. Alright, so from there, what we're going to do is draw the net for the rectangular prism below, and then label the edges of the net. So kind of the same thing here, got to be a little bit more precise, just because we want to make sure that we are able to find where our measurements are. Okay, so I'm going to draw, I got 1, 2, 3, 4 rectangular pieces, but they're all a little bit different. Okay, so we have one rectangular piece, the base, that goes like this. It's 10 and 2. Okay, and then our next rectangular piece will be this face. Maybe I should have drawn that, shouldn't have labeled that so fast, but this face will be 10 and 3. Next will be 10 and 2. The next will be 10 and 3. Okay, because this is 10 and 2. If we look at this face here, this next, this height's 3, so it's 10 across, 3 up. Okay, and so that's where we're getting those values from. Okay, and then from there, it really doesn't matter where we connect these edge pieces. I do know that the dimensions of the edge is going to be a 2 by 3. So I have this as 2. This height's will be 3. I can do that same way over on this side. This is 3. I'll say this height is. Okay, so this height's 3. This is 2. Okay, so when we fold them all up, we have 6 faces, like we have 1, 2, 3, 4, 5, 6. Okay, we fold them all up, close up the box. We'd have our rectangular prism. Okay, so as you work more with these nets, it'll be a little bit easier to see if you can't see it now. But it's one of those things where practice makes it more bearable. Okay, so from there now we are going to use Euler's formula. Now Euler's formula is a formula that relates the number of faces, edges, and vertices. Okay, and that formula is the number of faces plus the number of vertices equals the number of edges plus 2. Okay, so there are always 2 more faces and vertices than there are edges. Okay, so I'm going to have you guys use this formula to solve this problem. Okay, so bring that problem in complete. I know that you listened to it, gave some effort towards this. Okay. All right, now let's look at this next problem, a little bit more challenging. It says a certain polyhedron has twice as many edges as vertices. If there are 11 faces, how many edges and vertices does this polyhedron have? Okay, so I'm going to use the Euler's formula. They're talking about vertices, edges, and what they told us was that there are twice as many edges as vertices. So I don't know how many vertices there are. I'm going to put x, and I know that there are twice as many edges, so 2x for the edges. And so in order to find how many edges and faces there are, I'm going to use Euler's formula, which says f plus v equals e plus 2. They told us that there are 11 faces. Again, don't know how many vertices, equals 2x plus 2. Okay, so now as we solve this, I'm going to subtract x from both sides. I'm going to subtract 2 from both sides, and I get x equals 9. So, x equals 9. I know there are 9 vertices, just from where I wrote stuff. I know there are 18 edges. Okay, if you can do this one, you can surely do this one with no unknowns other than edges. Okay. All right, this is our start of our 3-dimensional unit. See ya.